I'm analyzing a linear regression model's performance, and the data has multicollinearity, high correlation between features. I need to find the best way to spot problems caused by this multicollinearity using Sklearn tools. This shows the model's coefficients, the numbers that multiply each feature. Large differences in these values, or values that contradict what I expect, could signal multicollinearity. It's not a direct measure, but it gives me clues. This calculates R-squared, which tells me how well the model fits the data. A low R-squared is bad, but it doesn't directly mean there's multicollinearity. Likewise, a high R-squared doesn't guarantee it's absent. This is key. It computes the condition number of my feature matrix, x_train, which shows how much the coefficients change if I slightly change the input data. A high number, usually above 1000, strongly suggests multicollinearity. This is for tree-based models, not linear regression. I shouldn't use it here. I used to calculate the condition number of the training data's feature matrix. This number tells me how sensitive the model's coefficients are to tiny changes in the data. A large condition number, usually above 1000, is a big red flag, suggesting strong multicollinearity, meaning the features are highly correlated and impacting the reliability of my model's coefficients. Think of it like this. A wobbly tower is highly sensitive to even a small gust of wind. Similarly, a high condition number means small changes in my data will wildly change my model's coefficients. That's not good. Both methods are valuable. MODELCOEF gives me a feel for the stability of my coefficients, while gives me a precise measure of multicollinearity's strength. By combining these I obtain a clear diagnostic assessment. That's how you diagnose multicollinearity like a pro. I examine the MODELCOEF attribute, which contains the coefficients of my linear regression model. Large differences in magnitude between coefficients, or even coefficients with unexpected signs, positive where I'd expect negative and vice versa, might show that multicollinearity is at play. These unstable coefficients are a strong hint, not a definite proof, but worth looking out for. I'm tackling the challenge of figuring out how to spot multicollinearity. That's when predictor variables in your model are too strongly related, in a linear regression model. It's a common problem that can mess with your results. I'm working with a linear regression model, and my data has multicollinearity. That means some of my input variables are highly correlated. This situation can make my model's results unstable and hard to interpret. I need to find ways to detect this issue. I'm exploring different ways to find this multicollinearity problem. I'll look at techniques that can help me discover if my predictor variables are too tightly linked. This model, attribute shows me the coefficients, the numbers that show how much each predictor variable affects the outcome, in my linear regression model. If I see some coefficients are huge, some are tiny, or have opposite signs than what I would expect, that could be a hint that multicollinearity is the culprit. This is a really important tool. The code "np lena lg cont x_train values" calculates the condition number of my training data's feature matrix, x_train. A high condition number, usually above 1000, is a strong sign that I have multicollinearity. This model score function gives me the R-squared score, which shows how well my model fits the data. A low R-squared score means my model doesn't fit well, but it doesn't tell me directly if it's because of multicollinearity. A high R-squared score doesn't rule out the possibility of multicollinearity either. I need to remember that model feature_importances_ is only useful for tree-based models, like random forests, not for linear regression models like the one I'm using. I'm zeroing in on the methods that are most effective at helping me figure out if I have a multicollinearity problem. I want to make sure I use the right tools to get accurate results. I'm tackling the challenge of identifying multicollinearity, which is when predictor variables in a linear regression model are highly correlated. This creates instability and makes interpreting the model's results difficult. I'm looking for the best ways to spot this problem. I'm using the popular Python library, Sklearn, to build my linear regression model. The data I'm using has multicollinearity, which means some of the input features are highly correlated with each other. I need to find the most effective tools within Sklearn to identify and address this issue. This is a powerful tool. I'm calculating the condition number of the training data's feature matrix, x_train, using NumPy's NP linear algebra module. A large condition number, typically above 1000, strongly indicates multicollinearity. This directly tells me how sensitive my model's coefficients are to tiny changes in the input data, a key symptom of multicollinearity. I'm using this to get the R-squared value, a measure of how well the model fits the data. However, a high R-squared doesn't automatically mean there's no multicollinearity. Similarly, a low R-squared doesn't necessarily mean there is multicollinearity. It's a general performance metric and not a direct indicator of multicollinearity. This is used for tree-based models like random forests, but it's not directly applicable to linear regression models, which is what I'm working with. I'm examining the coefficients of my linear regression model. Large variations in coefficient values, some very large, others small or even opposite of what I expect, can be a clue to multicollinearity. While not definitive proof, it's a strong hint that I should investigate further. I'm tackling the challenge of identifying multicollinearity, which is when predictor variables in your model are too highly correlated. This is a big problem because it makes it difficult to understand how each variable truly affects the outcome. I'll explain how to spot it using the tools provided by Sklearn, Sklearn, a popular machine learning library in Python. Let's dive in. We're dealing with a linear regression model in Sklearn, trained on data where the features are highly correlated. I need to find the best way to use Sklearn's built-in tools to identify this problem. This is a common issue in data analysis, so it's great you're learning to detect it. This gives me the coefficients, the numbers that show how much each feature impacts the outcome. If I see some coefficients are huge and others are tiny, or if their signs are surprising, it could signal multicollinearity. It's not definitive, but it's a warning sign. This calculates the R-squared, showing how well the model fits the data. A high R-squared is generally good, but it won't tell me directly about multicollinearity. I could have a great fit even if my features are highly correlated. This is the key method. It calculates the condition number of my training data matrix. A high condition number, above 1000, generally, means the coefficients are very sensitive to tiny data changes, a classic sign of multicollinearity. This is for tree-based models, like random forests, not linear regression models. My linear model doesn't have this attribute. I'll provide a complete explanation and visualizations, if possible, for each of the options presented in order to guide you to the most appropriate solution to the problem. I'm analyzing a linear regression model's performance, and the features show multicollinearity. I need to find the best way to spot problems caused by this multicollinearity using Sklearn tools. This shows the linear regression model's coefficients. Large differences in these coefficients, or coefficients with unexpected signs, could mean multicollinearity. It's not a direct measure, but it gives me a clue. This gives the R-squared score, showing how well the model fits the data. However, a high or low R-squared doesn't directly tell me if multicollinearity is present. This is really important. It calculates the condition number of the training data's feature matrix using NumPy, abbreviated _NP. A high condition number, usually over 1000, is a strong sign of multicollinearity. Because it shows how sensitive the model's coefficients are to small data changes. This is for tree-based models, not linear regression models, so it isn't helpful here. I'm looking at _NP. Lena LG. Cond, x_train. Values, . This calculates the condition number of your training data's feature matrix using NumPy's linear algebra functions. A high condition number, usually above 1000, is a strong signal of multicollinearity, meaning your predictor variables are too highly correlated. Think of it like this. A wobbly tower is hard to stand on, right? A high condition number is like that wobbly tower. Your model's coefficients are very sensitive to small changes in the data because of the high correlation between features. Here, I see model. _. This gives you the coefficients of your linear regression model. If you have multicollinearity, These coefficients might be unexpectedly large, small, or even have signs that don't make intuitive sense. It's not a direct measure, but it flags a problem area. It's an indirect clue. This is the main question. We need to determine which methods directly or indirectly help you detect multicollinearity in a linear regression model built with Sklearn. Remember, multicollinearity is when your predictor variables are strongly related, and this affects how reliable your model's estimates are. This instruction tells us that more than one option might correctly identify multicollinearity in this scenario. I need to select all the methods that are beneficial to discover multicollinearity.